On April 28, 2026, the industry saw two massive shifts: the decoupling of the Microsoft OpenAI alliance and the rise of autonomous development leads. OpenAI is no longer exclusive to Azure, signaling a fragmented, competitive market for frontier models, while IBM's new Bob framework proves AI is moving from coding helper to project manager. Beyond the boardroom, the technology itself is evolving. David Silver's new $1.1 billion venture, Ineffable Intelligence, is moving away from fossil fuel human data towards self-learning systems. We're also seeing the physical limits of AI, with Meta exploring space-based solar power to fuel its data centers. From the surge of AI jobs in India to the potential death of the smartphone app, the message is clear. AI is no longer a tool we use, it's the infrastructure we live in. Welcome to Anuku.com, AI news you can use, your daily dose of AI know-how. Across the entire tech ecosystem right now, there is an incredibly clear unifying shift. We are moving away from a model-centric world where people just marvel at clever chatbots and into a system-centric reality. AI is no longer just functioning as an assistant. It is operating as a fully autonomous partner. And today we're going to look exactly at how that shift is breaking our energy grid, tearing apart the biggest corporate alliances in tech, and forcing entire nations to redraw their borders. Let's start with what might be the clearest example of this transition to date: IBM's launch of an AI named Bob. Now, Bob is not a coding assistant. Bob is explicitly built as an AI-first end-to-end technical lead for the software development lifecycle. To really understand the magnitude of that, consider what a technical lead actually does in the real world. They don't just type code. They plan the entire architecture, delegate tasks, run security audits, and manage the timeline. Bob is doing all of that through a new framework called agentic orchestration. Agentic orchestration basically means multiple AI agents working together to manage complex workflows automatically without needing you to hold their hand. It is exactly like going from buying a really good spell checker to handing over the keys to your entire drafting department. When Bob is handed a 30-day legacy modernization task, it just handles it. It breaks the task down into subtasks, and then, using a multi-model orchestration layer, it basically holds auditions. It looks at a massive coding project and decides that Anthropic's Claude model is much better at complex logic for a specific piece, but IBM's own Granite model, or maybe Mistral, is way cheaper for just the basic formatting. It routes those tasks to different specialized models based on cost and capability in real time. Bob acts as the general contractor. It hires AI subcontractors, audits their work through a system called Bobshell, and runs automated AI red teaming to actively hunt for security flaws. It manages the whole pipeline, stitches it all back together, and the result is cutting a standard 30-day enterprise task down to just 3 days. Think of traditional AI models like a brilliant scholar locked in a windowless library. They know almost everything, but they can't actually do anything with that knowledge. Agentic orchestration is basically giving that scholar a telephone, a corporate credit card, and an entire team of interns. Analysts are calling the technology that enables this AI runtime layers, and it is officially the fastest growing software category of 2026. These runtime layers act as the operating system for AI, managing memory and automatically switching models to save costs. But you might be wondering, how does this AI general contractor actually interact with a company's old, messy data? A brilliant AI is absolutely useless if it can't read the proprietary files on a company's own servers. That has historically been the missing link, often referred to as the context gap. An AI couldn't securely or persistently access an enterprise's deeply buried data because it was either too risky or too complex. Now, companies like Appian have solved this by adopting the Model Context Protocol, or MCP. MCP is a standardized, secure pipeline. It allows an AI agent to interface directly and securely with massive, complex enterprise databases like Snowflake Cortex AI for data-backed decision-making. It gives the AI persistent memory and secure read-write access across totally different business processes. So the AI doesn't just answer a question and then immediately forget the conversation. It actually remembers the context of your business day after day. This transformation is bleeding far beyond software development. Over in the finance sector, Bloomberg is rolling out a chatbot-style interface called Ask B directly into its iconic terminal. Traders aren't pulling data manually anymore. They are using natural language to command an agent to query complex financial datasets. The shift in medicine is even wilder. The Stanford HAI 2026 AI Index Report literally declared 2025 and 2026 the years AI closed the loop on scientific discovery. Ambient AI scribes, systems that listen to a doctor's visit and automatically update the medical record, are now standardly deployed in 60% of major health systems. And the automotive sector metrics are perhaps the most striking indicator of this acceleration. General Motors designers are currently using tools like Viscom to turn hand-drawn sketches into fully realized 3D models and animations in a matter of hours rather than weeks or months. Jaguar Land Rover is using AI to simulate aerodynamic testing, taking a process that used to require 4 hours of intense compute time down to a single minute. Nissan has integrated AI unit testing to the point where they are slashing their total car development time to just 30 months, which is about half the historical industry standard. If we look at the underlying trend across all these examples, it signals a massive shift in human capital. The primary skill in the modern economy is pivoting entirely. Whether you are designing a vehicle, trading equities, or writing software, your value is shifting away from executing tasks. Your value now lies entirely in orchestrating the AI agents that execute those tasks. We are seeing this reflected clearly in the labor market. A new LinkedIn report tracking the global decentralization of AI development shows a massive 59.5% surge in AI engineering job postings year on year in India alone. And these aren't job postings for researchers in white lab coats building foundational models. The demand is almost exclusively for applied AI, engineers who actually know how to deploy, manage, and maintain these agentic systems. India is cementing itself as the world's high-end AI back office for deployment. But here is where things get complicated. Having millions of highly capable AI agents with persistent memory running complex multi-day workflows across the globe introduces a severe physical constraint. The cloud is just someone else's computer. All this brilliant, endless memory doesn't exist in the ether. It runs on metal, and it draws incredible amounts of power. To maintain an AI agent that can manage a 30-day software project like Bob, the system needs to remember what happened on day 1, day 12, and day 29. It needs an enormous context window. Keeping that context window open takes a staggering amount of working memory, which is extraordinarily expensive. Google Research just detailed a major breakthrough here called TurboQuant. TurboQuant mathematically compresses the key value cache during large language model inference. To break that down simply, think of the key value cache as the AI's short-term working memory scratchpad. When an AI reads a prompt and generates a response, it stores the mathematical representations of previous words, the keys and values, so it doesn't have to recalculate the entire conversation every single time it generates a new word. It saves time. But as a conversation gets longer, that scratchpad gets enormous, eating up incredibly expensive hardware memory. For a 30-day project, it becomes impossibly large and would normally crash the system. TurboQuant mathematically compresses that scratchpad, allowing for a 10 times larger context window on existing hardware. They are optimizing memory specifically to make this kind of infinite memory economically viable for real-time agents. But software compression only gets you so far. Eventually, you hit a wall, and the hardware side is where the physical limits of our planet are truly being tested right now. Supermicro just debuted new ARM-based AGI CPUs specifically designed for these high-density requirements. These systems require specialized liquid cooling because the silicon is running so unbelievably hot that traditional fans literally cannot move enough air to keep them from melting. And all that heat represents energy. The rapid expansion of these AI data centers has driven a 66% surge in natural gas power plant costs worldwide. Energy, quite simply, is the new bottleneck. We've reached a point where we are no longer constrained by algorithmic human ingenuity. We're constrained by thermodynamics. It's just basic physics. The absolute obsession across the tech sector right now is performance per watt. And the desperation for power is pushing companies to solutions that sound completely fictional. For example, Meta used more than 18,000 gigawatt hours of electricity in 2024 to power its data centers. That is enough to power 1.7 million homes for an entire year. Meta wants to shift to renewable energy, committing to 30 gigawatts of clean power. But solar power has a very human, very obvious flaw. The sun goes down at night, and AI data centers run 24/7. So Meta just signed a deal with a startup called Overview Energy to invest in space-based solar power. Overview is to launch a constellation of 1,000 satellites by 2030 to collect solar energy in orbit, convert it to near-infrared light, and beam it straight down to solar farms on Earth. They are planning their first real satellite test in 2028. It is an audacious engineering goal, but the underlying physics are highly advantageous. In orbit, there is no atmospheric diffusion, no weather, and no night cycle. A solar panel in space can generate significantly more power constantly compared to the exact same panel down on Earth. And while you might wonder why we don't just build localized nuclear reactors next to data centers here on Earth, nuclear faces a severe temporal bottleneck. Permitting, designing, and building a modular nuclear reactor can take a decade or more due to heavy regulation. Tech companies need power today. Overview. Energy argues that satellites can be manufactured and deployed iteratively, scaling the power supply much faster than Earth-based nuclear projects. Furthermore, the near-infrared beam they plan to use is entirely safe to look at, avoiding the regulatory nightmare of beaming microwaves or visible lasers through commercial airspace. Even if the infrared beam is perfectly safe, the sheer fact that we are legitimately considering orbital infrastructure just to keep these models running proves the point. Energy, not silicon chips, is becoming the ultimate currency of AI. And when the infrastructure to build and run this technology becomes this unimaginably expensive, it shatters existing business models. We are seeing the great decoupling of tech's biggest alliances. The cost of training and running frontier models has fundamentally altered the most powerful partnership in the entire industry, Microsoft and OpenAI. The divorce is official. Microsoft's exclusive license over OpenAI's models is finished. OpenAI can now sell its technology directly to Microsoft's fiercest cloud competitors, and they immediately capitalized on that newfound freedom by settling legal disputes and signing a massive $50 billion deal with Amazon Web Services. Now, Microsoft doesn't walk away empty-handed. They keep IP rights through 2032, and they maintain a massive 27% stake in OpenAI, worth about $135 billion. But the revenue sharing is now strictly capped through 2030, and Microsoft is no longer sharing revenue back. But here is the most telling detail. That famous AGI clause, the one that stipulated Microsoft's rights would immediately terminate if OpenAI ever achieved artificial general intelligence, was quietly scrubbed from the contracts, just completely gone. The removal of that clause signals a transition from idealism to harsh economic reality. OpenAI missed its IPO revenue and user targets. They are looking at the staggering energy and compute costs we just discussed, and they need cash. At the same time, the foundational model layer itself is commoditizing. Anthropic is hitting valuations approaching $1 trillion on secondary markets. Anthropic also just suffered a major security incident where their unreleased highly advanced agentic model, Mythos, leaked to the public through a third-party testing partner. So everyone knows exactly how good it is now. The competition is breathing down OpenAI's neck. In response to all that pressure, OpenAI released GPT 5.5. It came with a price increase, but the primary selling point wasn't just raw intelligence. This time, it was a claim of 40% better token efficiency. Again, returning to that core concept of performance per watt. It is a desperate scramble to offer cheaper compute. But OpenAI doesn't just want to win the cloud war by offering cheaper tokens to developers. They are trying to render the cloud ecosystem, as it currently exists, basically irrelevant. This is where the hardware strategy comes in. Supply chain analysts are reporting that OpenAI is partnering with Qualcomm, MediaTek, and Luxshare to build a proprietary AI-first smartphone slated for mass production in 2028. It is a completely new device paradigm. The software structure for this kind of device is already emerging. We're seeing startups like Sky securing massive funding to build AI-powered home screens that dynamically organize tasks based on behavioral predictions, entirely replacing the concept of navigating through separate static apps. The strategic logic here is deeply rooted in the history of computing. Whoever controls the interface controls the economic ecosystem. Currently, if OpenAI releases an app on iOS or Android, they are subject to an ecosystem tax, often around 33%, and they are totally beholden to Apple or Google's hardware constraints. They don't want to be an app on someone else's property anymore. To secure long-term dominance, they need the ultimate control surface, which is the smartphone. The smartphone possesses your camera, your microphone, your biometric data, your location, your payment rails, everything. It's the remote control for your life. In the post-app era, you won't manually switch between a banking application and an email client. Your local AI agent will live on the device hardware, orchestrating those workflows seamlessly in the background. OpenAI's move into hardware is an aggressive attempt to own that direct relationship with you. While corporations fight over the smartphone control surface, entire nations are fighting over the sovereign territory of AI itself. This is a profound shift in geopolitical strategy. AI is no longer categorized merely as a software product. It is being treated as strategic national infrastructure on par with power grids, highways, or military defense systems. Governments are literally drawing borders in code. Chinese regulators just stepped in to block Meta's $2 billion acquisition of an AI startup called Manus, ordering the deal unwound and explicitly citing national security concerns regarding the transfer of advanced models. Over in Canada, the government, through TELUS and LSpark, just funded a sovereign AI accelerator powered by a supercomputer running on 99% renewable energy. The goal there is absolute independence, allowing domestic startups to train models without routing their proprietary data through foreign-owned cloud providers. And in Europe, they are aggressively accelerating legislative pushes to mandate domestic cloud infrastructure over US-based software. Governments have collectively realized that whoever controls the underlying foundational models controls the economic output and the data security of the nation. They cannot rely on American tech companies forever, and the risks of democratized AI are simply too high to ignore. For instance, the FTC just reported a $2.1 billion loss to social media scams in 2025 alone, driven almost entirely by the proliferation of AI-generated content and highly sophisticated impersonation tools. The technology has been weaponized at scale, forcing a massive coordinated regulatory push for AI safety and national ring fencing. We are watching the digital space fracture into distinct, heavily guarded national territories, complete with export controls and intense security scrutiny. But there is a massive paradox in all of this. While governments are desperately trying to box AI in and control its development, the technology's architecture is moving toward total autonomy. It's outgrowing the box. And that points us toward the ultimate objective of all this infrastructure and investment, the quest for artificial general intelligence. David Silver, the co-founder of DeepMind, just launched a new AI lab in London called Ineffable Intelligence, backed by an astonishing $1.1 billion in seed funding. Their stated goal is to build a superlearner, and their premise fundamentally challenges how AI has been built up to this point. They want to build an AI that learns entirely without human data. Historically, large language models have been trained by scraping the internet. They consume human text, human code, human images, everything we've ever created. Silver characterizes this reliance on human data as a fossil fuel because it's finite. We are rapidly running out of high-quality text to scrape, and crucially, it is inherently limited by the ceiling of human capability. An AI trained solely on human data can only ever mimic human intelligence. It cannot surpass it. Silver wants to transition to a renewable fuel, which means learning through simulated experience. Instead of reading a textbook about physics written by a human, the AI interacts within a highly advanced physics engine. It learns the laws of the universe through trial and error, millions of times faster than real time. We are already seeing the precursors to this right now. Researchers have recently demonstrated self-improving AI frameworks that can actually beat human design baselines in creating new machine learning architectures. The AI is literally optimizing its own structural brain. It doesn't need a human engineer to tweak its code anymore. When an AI system can recursively improve its own architecture, test itself in simulated environments, and learn without human curated datasets, the pace of technological advancement becomes entirely decoupled from the speed of human thought. Before we get into the final takeaways, just a reminder that you can find more insights like this at inuku.com. Let's synthesize exactly what this all means for you, listening right now. We started by looking at Bob, the AI agent that isn't just helping you write code, but acting as your full technical lead, completely shifting human value in the workplace from execution to orchestration. We explored how giving these agents the persistent memory to manage massive enterprise projects requires so much compute that it's breaking the global energy grid, literally forcing companies like Meta to look at beaming solar power down from orbit with space lasers. We saw how the staggering cost of that physical infrastructure forced Microsoft and OpenAI to rewrite their vows and end their exclusivity, kicking off a race to build a post-app AI smartphone that bypasses Apple and Google entirely. We watched nations weaponize regulations to protect their sovereign AI borders as the technology fractures the global internet. And finally, we arrived at the precipice of AI systems that are decoupling from human data entirely, learning and optimizing their own brains in closed simulations. We've talked extensively today about AI agents becoming our partners, managing our legacy databases, acting as our hiring managers, and eventually running the workflows on our future devices. They are becoming the invisible layer between us and everything we do. But consider the trajectory of self-improving systems. What happens when these millions of autonomous AI agents inevitably begin interacting almost exclusively with each other? If they are negotiating tasks, trading compute resources, and optimizing workflows back and forth at the speed of light across global networks, human language is going to become a massive bottleneck for them. We are simply too slow. How long until English or any human language becomes too inefficient for them? How long until these agents develop their own highly compressed, completely incomprehensible way to communicate with one another, leaving us staring at our screens, entirely unable to understand the dialogue happening right beneath our fingertips? We started today talking about how clear things used to be. You click a button, the tool works. Now the tool is an autonomous partner, and tomorrow it might not even speak a language we can comprehend. And that's your daily dose of AI know-how from inuku.com, AI news you can use. The biggest takeaway today is that your value in the economy is no longer about how well you execute a task, but how masterfully you orchestrate the autonomous systems doing the execution. Keep questioning the systems building the world around you, and we will catch you next time.